Hello, physicists! Today we will be reviewing rules for significant figures. I have two helpers with me today, Anna.
Hello.
And JD.
Hey guys.
Alright, so with my helpers, we are going to get started. Without further ado, let's begin, physicists. The first rule for significant figures is that all non-zero digits are significant.
The second rule for significant figures is that all zeros between non-zero digits are significant. For example, in the number 70.2, since the zeros between the 7 and the 2, it also counts as a significant digit.
Alright, rule number 3. Any zeros to the right of the decimal point and end in the number are significant. So for example, 1.0, since the 0 is after the decimal point, has 2 Sig Figs. And 10, since there is no number to the right of the decimal point, only has 1 Sig Fig.
Thank you, JD. Now, folks at home, Rule 3 can be a little tricky, but there's a great way that you can check out Rule 3. And it's actually something you've done before, and that's by taking the number and placing it in proper scientific notation. So, for example, let's say we had the number 0.010. Holy cow, there are 3 zeros in there, and it can be a tad confusing as to, okay, side of the decimal point, and okay, end of the number, start of the number, how will all these zeros shake out? But ultimately, if we were to take this number and move the decimal point so it was in proper scientific notation, that would mean that we were moving this decimal point 2 places over. So it was between this 1 and that last 0, leaving you with 1.0 times 10 to the minus 2. The coefficient in my proper scientific notation, that 1.0 that I have left there, represents all of my significant digits. So in the case of 0.010, there are only 2 significant digits, the 1 and the last 0 in the number. Let's try some examples. First off, the number 7,240. This number would have a grand total of 3 significant figures. And the rule for this would be rule number 1, that any digits that are non-zero are significant. And in this number we have 3 non-zero digits, the 7, the 2, and the 4, giving us a total of 3 Sig Figs.
The number 27.01 has a total of 4 significant figures. You can find that using rules 1 and 2. There are 3 non-zero digits, the 2, the 7, and the 1, and the 0 is captured between the 7 and the 1, making it significant.
Example number 3. The number 0.0130 has 3 significant figures. It will be the 1, the 3, and the last 0. All of these are because of rules 1 and rule 3. Now, the first 0, since it is to the right of the decimal place, should be significant, but it is not because it is in front of the first significant number.
For our next example, we have a number that looks very similar to the number JD had, 0.013. However, unlike the example JD just did, this number only has 2 significant figures. The reason being due to rules 1 and 3 yet again. We have the 1 and the 3 ending in the number. Those are definitely significant. And all of the zeros precede those significant digits. In other words, we don't have a 0 after the 1 or the 3, as well as being to the right of the decimal point. And because of those reasons, we only have 2 Sig Figs. Another way to check this again would have been to put the number in scientific notation, and the coefficient would lend us to how many Sig Figs we actually are dealing with.
The number 500,000 only has one significant figure. It's because of Rule 1. And the one significant figure is the number 5 because it's the only non-zero digit, and because there is no decimal point, none of those zeros would be significant.
The number 45 has 5 significant figures. The 4 and the 5 because they are non-zero digits because of rule number 1. And the zeros are all significant because they are to the right of the decimal place. And they're all ending the number because of rule number 3.
For the number 103.056, we will have a total of 6 significant figures here. And this is due to rule number 1, which accounts for the 1, the 3, the 5, and the 6. And then the 2 remaining zeros we have are sandwiched between significant figures, therefore also making them significant due to rule number 2.
The number 0.000247 only has 4 significant figures. You can use that using rule number 1, which accounts for the 2, the 4, and the 7, because those are all non-zero digits. Rule number 2 accounts for the 0 in between the 2 and the 4, because it is captured between the 2 and the 4, making it significant. And then using rule number 3, you can exclude the 4 zeros preceding the number, because even though 3 of those come after the decimal point, they do not end the number, so they are not significant.
The number 104,020 will have 5 significant figures, the 1, the 4, and the 2, because of rule number 1, stating that any number that is not a 0 will be significant, as well as the 0 between the 1 and the 4, and the 0 between the 4 and the 2, because of rule number 2, stating that any 0 separating 2 significant numbers will be significant.
And there you have it. The rules for counting significant figures. That's all we have for you today. Until next time, physicists. Until next time.